Hello everyone, in this video I'll be explaining you the problem minimum number of operations to have distinct elements. So it was asked in Leetcode Biweekly contest 172. So let's read out the problem. You are given an integer array nums. In one operation you remove the first three elements of the current array. If there are fewer than three elements remaining, all remaining elements are removed. Okay, repeat this operation until the array is empty or contains no duplicate values. So return an integer denoting number of operations required. Got it. So they have given certain test cases. Let's take this one, 383658. So let's go to the board. We have 3, 8, 3, 6, 5, 8 as the array nums, and yeah, we have this, and then I think length is this is the thing. Now in the question what they've said is we have given nums array, and we have given nums array and now first three elements we'll have to remove. First three elements we have to remove from the array, starting array. So whatever elements we have, let's say multiple, so first three, 1, 2, 3 elements you have to remove. So when you remove these three elements, it is regarded as one operation. Okay, it is like one operation you have performed. And yeah, they are asking one, it's like one operation performed, and they're asking you need to perform these operations unless and until the entire array is empty, or in the array you don't have any duplicate elements. Okay, so let's say you are having some array and then you have only two elements remaining. So in that case, since it is lesser than 3, you can remove all the elements. Okay, and this is also recorded as one operation. If let's say you have only one element remaining, you can just remove that, and that this is also recorded as one operation. So and if let's say you have like multiple elements and then all the elements are unique, so in that case you don't need to remove. Okay, you will have to stop the operations. So they're asking how many operations you will be doing. So okay, let's take this array, and then first three elements we'll try to remove. Since this array has 3 as duplicate, this is 3, 3 is 2 times, so it is duplicate. 8 is also 2 times, so it is also duplicated. So we will remove this element, and how many operations we have performed? One operation we have performed. Now your nums array looks like something this way, 6, 5, 8. Now since array is in nums, all the elements are unique, so you don't need to do any thing, don't perform any operation. So how many operations you perform? You just perform one operation. Okay, let's see second test case. We have 2 and 2, so this is second test case and this was first test case. Nums is like 2 comma 2 you we have. So since this array have duplicate elements, so we'll perform one operation, and we are allowed to remove 3 elements. Since we have only 2, remove all 2. So your array will have no empty, and when it is empty, so you have to stop the operation. So again here one operation you have done it. So we have one again here, and this one 4, 3, 5, 1, 2. So third test case if you take, it is 4, 3, 5, 1, 2. So in this, when you are trying to perform the operation, all array elements are unique. We don't have any duplicate elements, so you will not do any operation. So it's like here operation is 0. Okay, so I think question you have understood, but how do you solve this is the question. Let's try to see how do we solve this. So our main idea of this, in order to solve this would be, we just need to keep track of the nums array, like is there any duplicate elements. If it is there, then we need to perform the operation. Okay, so we need to keep track of duplicates. So when we do this, keep track of duplicates, and if we don't have any duplicate, then we don't need to perform operation. If we have duplicates, then remove first 3 elements. Okay, and when you're removing the elements you need to update the duplicate C. like do you have duplicates or not. So okay, how do you solve this now, is the question. So what I'll try to do is, in order to keep track of duplicates, I'll take one map, okay, in which I'll be storing key value pairs. 3 is like 2 times, 8 is like 2 times, 6 is like 1 time, 5 is like 1 time, 8 is a del. So okay, we have these things. Now when you look at this map, so you will have duplicates you have found, like one is unique only, but more than one is like duplicate. So we need to perform the operation. So okay, I'll be telling you how to iterate in map also, like this in order to keep track of this, I'll be using one more set data structure. So this is unordered map only, so just keeping track of uniqueness, I mean frequency. So I found the frequency. Now since frequency is there, our operation will be one operation we are doing it, okay. So your operation is going to increase by 1. Initially it was 0. Since map is this thing, now 3 elements you're removing, which means 3 you're removing, which means you need to reduce the frequency of 3, which is like 1. Then you will remove it, reduce the frequency of 8. Then you'll remove 3, reduce the frequency of this thing. When it is 0, remove from the map. You have done one operation. Now in the map, you'll say, do you have any element whose frequency is greater than 1? You don't have any, so stop the operation, which means these 3 you have removed. Now remaining is 6, 5, 8. So it's all unique only, which is depicted in the map. So yeah, this is kind of good only, but see, it's like 3 elements you will be removing, which is order of n. Into in map again will be in order to go in map and find if there are frequency greater than 1, this will take again of n operations. So it is going to be n square, okay. So yeah, it is going to be n square, because all n elements, if all elements are unique, let's say, so you'll go through all the elements and find its frequency. All will have 1, so you'll move till from initial to final, like from beginning to end you will move in the map. So it's n square. So how do we keep track of if there are duplicate elements? So for that, what I'll be using is, I'll use one set data structure. I'll use this is also unordered set only. Let me call set SAT. What I'll try to do is, initial take frequency of all. 8 is also frequency of 2. 3 is frequency is 2, 8 is 2, 6, 5, 1 is 6 and 5 is 1. Okay, we have this. So in this set data set, what I'll do is, whose frequency is greater than 1, those elements I'll put in my set, okay. And now this is my initial configuration. When I try to remove these 3 elements, first I'll check if we have any elements in the set. This set will keep track of duplicate elements, okay. So if its size is greater than 0, which means we have some elements. If it is not empty, which means we have some duplicate elements. So now these 3 elements we'll have to remove. So when we are removing these 3 elements, so first we'll remove 3, so its frequency is reduced. So now frequency of 3 is 1, so it's unique only, so we'll remove from this set as well, okay. We have removed from the set. Now we are removing 8. 8's frequency is 2, it is gone to 1, so we have 1. Frequency of 8 is 1, which is unique, so we'll remove from the set. It is empty now. We'll remove 3, it is 0, remove from the map this thing, got it. Now when you try to remove other 3 elements, now before that you will check if set is empty or not. If set is empty, which means we don't have any duplicate element, so it is kind of a condition given in the question, so we'll have to stop. So the thing is, we'll maintain 2, map and set data structure. Map to keep track of frequency, and then set to keep track of how many duplicates element are there, okay. So let's try to write pseudocode. I think pseudocode will be construct frequency map, and set data structure to maintain construct shared data structure to maintain duplicate elements. Okay, now remove 3 elements from the array. Before that, check the duplicacy. Okay, you should check the duplicate elements. So I think you've understood the how do we solve this problem. So let's try to code it up. So let me reset this code. So what I'll do is, first I'll take en as length of the array, then I'll take map, which will be unordered. This stores frequency of nums. Then I'll take unordered set. This keeps track of duplicate elements. Okay, now I'll let me use for each loop. I'll take one elements, and in map I'll make sure frequency of that element is increased, and if I find that this map of nums is frequency of this is greater than 1, which means it's in a duplicate, so I'll insert into set. So at this position we have constructed the frequency and duplicacy set. Now I'll take one loop. I'll take I, which will be initially 0, and this is n. Nums basically n is basically the size of the array. I'll take while I is less than n. Okay, so now what I'll try to do is, I'll try to check if st dot if st is empty, which means we don't have any element in the set. If we don't have any element in the set, which means we don't have any duplicate element in the array, in the remaining array, so we'll break out of the loop. So we'll take one more variable answer, which is initially answer, or you can say operations, which will make more sense. Operational input operationally, at the end we'll have to return operations. Okay, now if set is empty, which means we don't have any duplicate elements, so we'll break from the loop, or else now we'll have to check it, like what we'll have to check is we'll have to see first we'll have to decrease the frequency, right? So or in map, your nums of I minus minus, which means the frequency of this current number element present at I is decreased. We'll check if map of nums of I, if its frequency is 1, which means that element is no more duplicate in the array. Okay, so we'll have to remove from this set, and yeah, we'll have to basically remove from the set. So set dot arrays, we are removing from the set, and yeah, whenever map frequency is 0, so in that case we don't need to do anything, because as we know the frequency we have set it here, so it will not go negative, so it's fine. This is valid. So these things we'll have to do 3 times. Okay, so we'll have to do this 3 times. Let me take count. Count initially is, let's say, 0, while count is less than 3. So these operations we'll have to do, and every time we need to increase I. Okay, also count will have to increase. So this loop will execute 3 times. So once we come out of the loop, we'll have to this is like we are performing one operation. Okay, and not just count less than equals to, I mean less than 3, we'll have to check this as well, like, and I is less than n. It may happen that you have only two elements, so in that case this I will go into overflow. So for that reason I am checking I is less than n. Yeah, so I think this is going to work. Let's try to run it. Yeah, it is running fine. um, let's try to submit it. Yeah, it got accepted. So in the contest I think my solution was like uh, not readable. I has had put multiple line of code, but yeah, in this I think I put in while loop, so only it's like readable and then 3 times this executes. So I think you guys have understood the problem statement, and yeah, thank you guys for watching the video.